Our second lesson in 7.5, rationalizing denominators for lesson 2. So we're going to be rationalizing a denominator that has two terms. So like, for example, over here in the right, you see 4 over the square root of 5 plus 6. So I'm going to show you how we work and how we rationalize this type of a denominator. Before I do that, we have to review a concept that we have worked with back in chapter 5 when we would FOIL or distribute and multiply the products of a sum and a difference, because it had a special pattern for us. If you remember, the answers on this only gave us two terms. This has a special pattern. When I multiplied here, I would distribute x times x, and then x times minus 4, and then I had a plus 4x, and then I had a minus 16. If you remember this type of a pattern, when we do this, we had x squared, and then I would have minus 4x, and then I would have a plus 4x, and then I would have minus 16. And the key to this pattern, the key to this is right here in the middle. What makes this pattern special is that there is no middle term in my final answer. And why is that? It's because the middle term cancels. It goes away. It gets rid of the middle term. We have an opposite sitting here. Negative 4 plus 4 gives me 0. And my final answer on this one, when I actually multiply, oops, forgot it's 1 there. The final answer is x squared minus 16. We are going to use this idea of canceling a term to help us rationalize this type of a denominator up here over in the right corner, where I have 4 over the square root of 5 plus 6. So let's see how that works now. We're going to keep this idea out in front of us. How can I use this idea here on a problem that says 3 over 2 times the square root of 5 plus 1? Here's what we do. We're going to use this idea up here. I'm going to take and go times, and I'm going to times both the numerator and denominator times a new number now over here. And I'm going to use this idea. Well, if I had on the top, if I want to use this idea, and let's say I have in one set of parentheses 2 times the square root of 5 plus 1 in one set of parentheses, what can I multiply this by to get an answer like this where the middle term cancels? Well, I'd use 2 times the square root of 5 here. And I would use a 1 here. And what would my sign be in here? It would be a minus. So now I have something set up that will give me two terms and an answer. So if I actually do this, I do 2 times the square root of 5 times 2 times the square root of 5, I would get 4. And the square root of 5 times the square root of 5 is 5. So I get 4 times 5. Then I'm going to do 2 times the square root of 5 times negative 1. So that's minus 2 times the square root of 5. Because 2 times 1 is 2. Positive times a negative is a negative. And I have my square root of 5. Now I'm going to do 1 times 2 times the square root of 5. That gives me a positive 2 times the square root of 5. And then I have 1 times negative 1. So that's a minus 1. And I'll take a look. What happens here? I have a minus 2 square root of 5 and a plus 2 square root of 5. So what is going to happen with those terms? It's going to disappear. Take a look. Once I cross those out, what am I left with? I'm left with 4 times 5, which is 20, and a minus 1. I will now get the answer of 19 here. So let's see how that works with my fraction here. So I'm going to have it over here, and I will then write, if my denominator says 2 times the square root of 5 plus 1, I'm going to write, and it actually has a name called the conjugate, but we're going to keep in mind that this is the product of a sum and a difference. So we want since this one has a sum as in the denominator, I want the difference over here. So I write 2 times the square root of 5 minus 1. And I also do it on the top, because 2 times the square root of 5 minus 1, and I do it both top and bottom. What is the value of this fraction that I'm multiplying by? The value is 1. So I'm not changing the value of my original fraction. I am rationalizing it, and I am keeping the value that's there. I'll just have different numbers. So let's see how this turns out. So now I have 3 times 2 times the square root of 5, and then 3 times the minus 1. So I will have to distribute that, because this essentially is in parentheses. So 3 times 2 times the square root of 5 is 6 times the square root of 5. And then 3 times the minus 1 is minus 3. all over 2 times the square root of 5 times 2 times the square root of 5. As I showed you before, I do 2 times 2 is 4. The square root of 5 times the square root of 5 is 5. Underneath, because I know I'm using this, I'll have underneath here, I'll have 2 times the square root of 5 times the minus 1. Or I want to remember this pattern, my middle terms will disappear. So I can essentially, because I'm using this pattern, the product of a sum and a difference, I won't have to multiply those because I know the middle terms cancel. So now I'll just take the last term and I'm going to do 1 times negative 1. It's a minus 1. So how do I finish this off? I then finish it off by saying I have 6 times the square root of 5 minus 3 over 20 times 4 times 5 happens to be 20. And 20 minus 1 is 19. Now I have a rationalized denominator. So I know I'm dealing with 19ths. And I have the top that's 6 times the square root of 5 minus 3. Take a look at that for a second. If you have any questions, pause the video, come and ask me. I'll be happy to show you again. I will do more examples here. So let's take a look at another example together. Here's the square root of 5 plus 3 over the square root of 3 minus the square root of 2. All right, using the idea of the product of a sum and a difference. So I will then draw a fraction bar here. This one is a difference as in denominators. I want the sum. So I will write the square root of 3 plus the square root of 2. And I will do that on the top in the numerator, the square root of 3 plus the square root of 2. Again, this has a value of 1, so I'm not changing the value of the original fraction. I'm just changing the numbers. So let's take a look. First of all, let's do the numerator. So now I have to remember these two things are like they're in parentheses. So now I have to distribute these items. So I got to remember that it looks like that. If you need to, you draw in the parentheses like I did here. That'll help you remember to multiply that out, binomial times binomial. So as I'm writing here, I got the square root of 5 times the square root of 3. That's the square root of 15. Then square root of 5 times the square root of 2. That's plus the square root of 10. Then I have 3 times the square root of 3. So that's plus 3 times the square root of 3. And then 3 times the square root of 2. So it's plus 3 times the square root of 2. All over. Well, let's see. 3 times the square root of 3. I'm going to square that first term because I'm using the pattern of a product of a sum and a difference. That gives me 3. And then I don't have to worry about the middle term because the square root of 2 times the square root of 3 is the square root of 6. I'll have a minus square root of 6 here. When I multiply the outside ones, I get a positive square root of 6. Those cancel. So now I'm going to do the negative square root of 2 times the positive square root of 2, and I get a minus 2. 3 minus 2 gives me a nice easy answer. So then I have the square root of 15 plus the square root of 10 plus the square root of 3 times 3 times the square root of 3 plus 3 times the square root of 2. And I'm done because 3 minus 2 is over 1, and I don't have to write that any further. That's all the further I can go with this one. Yeah, a long answer, but that is how we do it. We have a rational denominator now of 1, so then I'm left with all of this here. All right, one more example. I know the video's reached 9 minutes already, but I'd like to do this with you. It does take some detail and time. So here we go. Last example. What am I multiplying by? 2 plus the square root of x. Product of a sum and a difference. Here's my sum. Here's my difference. 2 plus the square root of x. So again, now the numerator is like a monomial times a binomial. So I'll distribute 4 times the square root of x times 2. That equals 8 times the square root of x. Then I have 4 times the square root of x times the square root of x plus, well, square root of x times square root of x. A square root times itself always equals the number on the inside, that number. So I'll say it's 4x. All over. Since I'm using the pattern of a product of a sum and a difference, square the first term. 2 times 2, that's 4. The middle term will cancel, so now I can just do these negative square root of x times a positive square root of x gives me a minus x. And at that point, I can be done. That's it. There's nothing else to do. Sometimes an answer key might actually look at the numerator and pull out that factor of 4 and write it out that way. But written this way, it's also correct. And you can stop here. That I'd have 8 times the square root of x plus 4x all over 4 minus x. Now I have a rationalized denominator, and that's what we were asked to do right now in this lesson. So we don't need to go any further. Okay, the assignment. What I'd like for you to work on with this one is as follows. From page 448, I want you to do numbers 35 to 40 and 43 through 48. So 35 to 40, 43 to 38. We want to check answers again and turn it in when you finish. Go ahead and write that down. Get to work on it, or let me know what I can help you with.